Hello, honors pre-calculus students. Mr. Cazzato here. The learning target on this worksheet is to write the rational function given the information. So if you look at problem number 1 here, you can see that there is a horizontal asymptote at y equals 4. There is a vertical asymptote at x equals 2. We have a x-intercept, and it's labeled in the paragraph 5/4. That's the yellow one. And the green one is -6. So if you're to think about the function, the numerator is going to have x plus 6 and then 4x minus 5. One of your classmates explained if x is equal to 5 over 4, 4x is equal to 5, so 4x minus 5 is equal to 0, so that's how you get that factor. In the denominator, we have x equals 2, and since the graph is approaching that function in the same direction as I highlighted in blue, that exponent must be even, meaning it must be 2. And we're going to check it to make sure that this works by checking the y-intercept. So let's just check the y-intercept if we did this correctly. So f of 0 is going to be 6 times -5 over 4, which is going to be 3 times -5 over 2, which is -15/2, so it checks. Let's take a look at problem number 2. If you want to pause the screen and try it on your own first, please do so. So we have these x-intercepts, so we know the function will be x plus 4 and x plus 2, so f of x is going to be x plus 4 and x plus 2. We have a vertical asymptote at x equals 4 and x equals -5. So the denominator will be x plus 5 and x minus 4. The directions of the function are opposite, so those exponents are odd, so most likely they're going to be 1s. And we have a horizontal asymptote at y equals -2. If you were to multiply the function out the way it is right now, the horizontal asymptote will be at 1, because you're going to have x squared over an x squared. So to get the horizontal asymptote to be correct, we're going to put a factor of -2 in front. So I'm going to highlight that so you kind of see that. And now let's check the y-intercept. So f of 0 is going to be -2 times 4 times 2 over 5 times -4. The -4 reduces, the two negatives become positive, so you get 4/5, so it does check. Let's take a look at problem number 3 if you want to try this before I write the answer. So using the x-intercepts, we know the function f of x will have a numerator of x plus 1 and x plus 5. Now notice at the x plus 1, or at x equals -1, it just touches, so that needs to be an even power, and at the -5 it goes through. For the denominator, looks like we have x equals -3 and x is equal to 1. So for the denominator, we're going to have x plus 3 and x minus 1. Around the x equal 1, one part of the graph is up, the other part of the graph is down. But around the x equal -3, they're going in the same direction. So we're going to need an exponent of 2 around the x plus 3. I'm going to highlight that there because they're going in the same direction as I highlighted in blue. We also have a horizontal asymptote at y equals -5. So if you were to multiply this function out right now, you're going to have x cubed plus some other terms over x cubed plus some other terms. So the horizontal asymptote right now is at y equal 1. So in order to fix that, I'm going to put this factor of -5 in front. So I believe this is going to be the final answer, but I'm going to check it by using the y-intercept. So let's check it by calculating f of 0. So negative 5 times 1 times 5 over 9 times negative 1. The two negatives make a positive, so 25 over 9. And here in green, I give you the y-intercept, so that does check. So this is the function for that graph. So I could have just put a negative 5 up in the original, and then this would have been a negative 5, and then that would have worked out. Hope you found this useful. Let's take a look at problem number 4. So from the x-intercepts, we know the numerator is going to be x minus 3 and x plus 4. On both of those x-intercepts, it goes through, so the multiplicities are 1. For the denominator, we have x equals 2, and that's an odd multiplicity. We also have x equals negative 2, and notice they're approaching in the same direction. So we're going to have x plus 2, the quantity squared. Right now, if I were to multiply this out, it'll be x squared over x cubed, so the horizontal asymptote is accurate. So let's check the y-intercept. If I were to calculate f of 0, I get negative 3 times 4 over negative 2 times 4, which is 3/2. However, the y-intercept is negative 6, so it is not matching up. So you may remember in polynomials, there's this value of a that's possibly there. So if I were to redo this, f of 0 is a times negative 3 times 4 over negative 2 times 4. That's still going to be 3/2, and the y-intercept is negative 6. So it's negative 6 equals 3/2 a. So negative 12 is equal to 3a, which makes a negative 4. So the final function here is f of x is equal to negative 4, x minus 3, x plus 4, divided by the quantity, x minus 2, x plus 2 squared. So I'm going to highlight the final answer in yellow.